Okay, so with my talk, would like to kind of switch gears from the other talks, or rather take the gears apart, open up, look inside the engine. I am interested in collaborations, interdisciplinary collaborations, field building. I am an anthropologist of science and technology, and I have been aware of and interacting with and following developments in this kind of work for 6 or 7 years now, and very interesting, very exciting things are occurring, change is occurring. This kind of meeting to think about, we would get this many people, these kinds of people in a room, and they would have lots of common language to think about, common views of the future of the field. That was not apparent 6 or 7 years ago. And so watching the field develop, but also asking questions, okay, how do disciplinary interactions work? How do groups collaborate that have different mechanisms of support, different mechanisms of reward? How does innovation happen in those kind of settings? What does it take to build a new field? And so I come to this from previous work where I spent the better part of a decade in a particle physics synchrotron laboratory and looked at, okay, how did the groups work together inside of that setting? And in this particular situation, there were very different kind of groups. So you might say from the outside, oh, well, this is obviously everyone inside of a synchrotron is going to have a shared culture. They're going to have shared meanings. They're going to have shared systems of reward. They'll all just get along famously inside there. And so, but there were very different groups, and in this case there were groups of biologists and groups of physicists, and so I look at interdisciplinary interactions, and I do look in particular at science and non-science interactions, and thinking about this work you might say, hey, well these people are all scientists, but let me assure you, there were views in there where even from the outside it looks like everybody's doing science. Well, from the inside, some groups would say, hey, this group, they're not doing science. They're very unscientific. They don't understand how it goes. And in fact, that kind of dynamic, battle, if you were, about, well, what does it mean to do science? What does it mean to derive knowledge from the world? How does that work? That was very much contested. It was very much at stake, and it very much changed over the time of my looking at this at the laboratory. And so the laboratory is one of these big particle physics synchrotron laboratories. And the physicists had built this tool, this machine. They understood how to use it for their purposes. And then kind of came along ideas about, well, there might be other applications, other engagements with this kind of tool. And biologists said, well, we can use some of these techniques, this instrumentation, and instead of smashing subatomic particles together, we can look at the structure, atomic structure of particular proteins and viruses, okay? And so this was at the beginning, I would say the physicists said something along the lines of, well, we'll let you in the lab, and you can be here, but just don't say anything, and definitely don't ask us any questions. And then we will turn the machine on and do our thing. And if you want to do your thing while you're doing it, as long as it doesn't affect us in any way, shape, or form, go right ahead, okay? And so, interestingly, over the course of a decade or so, that situation changed dramatically. And so it did have to do with computation, computational power. the kind of work that biologists would do. An isolated biologist would work for some years trying to decode the atomic structure of a protein or virus. With computing power, those times changed from years for a particular molecule down to months, down to weeks. The field garnered publicity. It was related to important applications in health and medicine. People in biophysics, in particular this field was protein crystallography. Well, they're starting to get academic jobs, professor jobs. Funding is coming in for this kind of work. They are getting their work on the covers of important journals, Science and Nature, Cell. The editorial approach to those journals starts to cater to this kind of work. And the field begins to rise. And essentially, this is a story. It has revolution in the title. It's an action-adventure story. And the biologists come to dictate the terms of the laboratory. They come to decide, okay, this is what it means to do an experiment. This is what it means to generate knowledge. And our terms are going to dictate the show. We are going to curate how this technology and techniques of knowledge production are used. And so I think there are analogies to things that are going on now. There are similar contestations about what does it mean to produce knowledge, how do you use technology to do that. And so I'd like to say a little bit about kind of my early readings of what's happening. And I think I'll premise the entire kind of overview with I do have a conclusion that I think it behooves everyone here. I hear a lot of, everyone in this room is a proponent of change, a proponent of a new kind of way of doing a field, a proponent of beginning a new field and building it. That is an actual threat to the old field. So I think that it does behoove people engaging this to consider, when I saw this, when you give a presentation and it makes perfect sense to you and it's unbelievable and it's going to open up all these vistas and you've spent a lot of time working on it and isn't this amazing? And you kind of present it to a person, from the established field, and they're like looking at their watch and they're not listening and they're looking over your shoulder and answering texts, and you think, why are they not engaged by this? It's okay. I think we have to take seriously and consider that it's not for no reason that it is an actual threat. A threat to the old way of doing things, and now how do you engage that in a positive way? So my entree into this field and seeing this interactions has been through Professor Rick Johnson at Cornell. My office is a few doors down from his, and I used to walk by his office. I had a lot of important things to do. He would yell out the office door, "Hey, you should be studying me." He would tell me. I say, I have work to do, okay? I got things going on. So then I would kind of slide by, like I'd have the office, like duck under, so he wouldn't see me. But he's very perceptive, actually. Like it was really hard. It was really hard to sneak by him. Eventually, wore me down, and I entered into looking at this. And at the start of this morning, Louisa brought up kind of several dynamics of interaction that are occurring in the field, and that certainly we've seen examples of yesterday and today. And so she talked about art history as a field kind of asking computer science. That's one way it works. Like, hey, we are historians, we have a problem. Can you computer scientists do something about this? She talked about institutions finding computer scientists, but with the caveat that, okay, you computer scientists, can you work on it, and you'll need your own resources to do so. So, get your own resources, work on our problem and help us out. Talked about kind of digital humanities initiatives where, some of those are growing. I heard a term yesterday, arranged marriage, okay, and so it's like, okay, there's funding, there's institutional support, let's get these things together, and then the two, the betrothed are kind of like, okay, now what should we do here? How's this supposed to work? And then she talked about, well, also computer scientists, and we've seen examples of this, working on their own problems. So for whatever reason, they get interested and they take the initiative and they have their resources and they've come up with some amazing, incredible things. And so I would like to add one to that for the table and for discussion. And that is the computer scientist or engineer who gets involved, takes the initiative, but they don't know what the problem is. Okay, and so essentially I want to put in a plug, I would say, for infiltration. And so I've seen that bear some fruit. And let me talk about that a little bit. So yesterday it was the weave matching, canvas weave matching type project was brought up, and people are familiar with that in the room. And so, this was a project I know from following Rick and from the beginning where, okay, it wasn't known from the beginning what's going to happen. Rick was able to, because of his position in the university, get time away from the university. He took the initiative to get into the world of conservation, museum conservation, get through into the back rooms, and just hang around for a little while, kind of a la an anthropologist. And that took time. And from hanging around and kind of watching like, hey, what are you folks doing now? And they had the eyepiece and look at the weaves on the canvas, and they say, oh, well, we're counting the threads on the canvas. This is an important technique by which we figure things out, and it answers questions for us. And Rick's training as a computer scientist, signal processor, it says, look, okay, threads, this has periodicity, this has features. I can actually do some things that would help this process along. But the problem and the initiative for the project kind of arose, I would say, organically out of an open-ended type of interaction. And so something I would put forward is, okay, is there some way to institutionalize that? That's very difficult. Rick was able to do that because of his position. Is there a way through thinking about systems of support and reward in the different fields that those kind of open-ended interactions where there isn't necessarily even a known payoff, how could that be arranged? Okay, it's very hard. But it also is integral to building these kind of new fields, I assert. And so the weave matching project, this then led to kind of several other projects. These all had different institutions involved, different museums involved, different academic researchers involved. Many of them are sitting in the room. The weave matching then kind of led to photographic paper analysis. Again, there's periodicity. You can analyze it. You can extract information about it. As I say, collaborators are sitting in the room on these projects, different kind of institutions. I was there at a kind of conference where Rick was talking about weave matching, and people said, hey, we have chain lines in paper, we have watermarks. I guess it's hard to see in that image, but we do a lot of work classifying watermarks. Actually, a lot of the papers were cut and the watermark isn't there, but the chain lines are there. Is there kind of any way we can work with that? And again, that led to collaborations with museums, academic institutions, different kinds of funding agencies, the CRES, NSF more recently. And so I'll just kind of, one more of those is thinking about Chinese silk as a material. And again, it's not the same as a weave map. Sometimes there are two threads over one thread, but it still has periodicity to the signal processor. They look at that and say, we can extract information. There are things that can be done. And so, what I've seen so far, and as I say, this is initial, ongoing. This type of meeting is my research. And so these results came out of what I would say an open-ended interaction at the beginning. That might seem very hard to institutionalize, but I think it seems to me that it's important, integral, and I did see that in my previous work. So we have a kind of, just my last slide here, some advice, if you were, to engineers kind of getting involved with this. This is something we did kind of jointly publish in IEEE. And so this is all premised on, something that resonates with me from my earlier work, that look, you're an engineer, you're getting into this field. It doesn't behoove you to pretend that it's not a threat, that the threat is not real. There are stakes involved for the field that's there already, and now how do you engage that in a positive way? So these are just kind of general, what would you call them, manners or something, finishing school or something for engineers to interact. They need it, yeah, I can tell you that. And so, this is like, don't charge in like the bull in the china shop. The idea is not, here's what we can do, now you don't have to do it anymore. People generally don't like those kind of conversations. This was something that in order to kind of get engagements that are going to last, it's maybe a call to think local. Maybe like all politics are local. That's a saying. And so, can problems be picked that definitely are of interest to art historians, but also have an accepted answer. And so a smaller problem at the start, the collaboration interacts. To the art historian, they're like, look, this is what we would do, and we expect to get this answer, and then the collaboration provides that answer. It's a calibration, if you were. You might call it interdisciplinary, intercultural calibration. And then there's more of the kind of trust that was talked about earlier built up. Now maybe we can dream bigger, dream more pie in the sky. The data issue is a huge issue. As all of you know, in many of the talks yesterday, it's okay, we have these systems, and as long as we have a giant annotated data set, we can do all these things for you. Okay, how do you obtain this? And we heard earlier today, look, data is, it's money, it's property. Many situations, people want to keep that information to themselves. And how is that going to be handled? This is just really a call for engineers not to presume that data is out there and it'll simply be handed over to do projects. And this is, I guess, the finishing school approach. This is good advice for life. Go through with like awareness and humility. And so. I think this is all in the beginning stages. I'm happy to talk with everyone. And I just would kind of put a call for, it was mentioned, well, and maybe in the roundtables that we talked about, what are kind of the ethical implications for thinking about these kind of things? I teach classes in ethics and science and technology, and the threat is real here. Things are changing, and when you approach a field like art history, okay, maybe 10 years ago, 20 years ago, an art historian, they're working in some kind of archive somewhere. They have a book from who knows how long ago. They have white gloves on. They're looking at the images. In their mind, they are not thinking to themselves like, well, gee, how is my work right now engaging the avant-garde technologies of the military-industrial complex, okay? And so I think a lot of art historians, that was something like for a person that may be like important to them, you know, that may be like a reason they are not working for IBM or Lockheed Martin. You know, this is why they went into their career. And so it's not nothing to say, okay, now you're going to be engaging and using the same kind of video recognition and facial recognition that we use to target insurgents in Iraq, okay? And so, you know, I don't think you can just gloss over that kind of stuff. Okay, now that you're more aware and humble, I will endeavor to do the same thing and look forward to talking with you. Thank you.